Imagine an engine so loud you could hear it coming from 3 blocks away, so distinctive that truck drivers could identify the model by sound alone, and so revolutionary it changed the entire industry. Detroit Diesel wasn't just another engine manufacturer. For decades, it was the heartbeat of American industry, powering everything from cross-country big rigs to city buses, from tugboats to generator sets. But here's the shocking truth. The very innovations that made Detroit Diesel legendary were also the seeds of its downfall. This is the story of how America's most iconic engine company rose to dominance, stumbled under its own success, and ultimately lost its independence to foreign ownership. The story begins in 1938, in the shadow of the Great Depression. General Motors, already a manufacturing titan, saw an opportunity in the diesel engine market that others had overlooked. While competitors focused on agricultural and stationary applications, GM's new Detroit Diesel engine division had a different vision: lightweight, high-revving diesel engines that could compete with gasoline power. The timing was perfect. America was modernizing its infrastructure, cities were expanding their transit systems, and the trucking industry was about to explode. But the diesel engines available at the time were heavy, slow-turning behemoths, designed for ships and factories, not the dynamic demands of over-the-road trucking. Charles Kettering, GM's legendary engineering chief, assembled a team with a radical mandate: build a diesel engine that could revolutionize transportation. What they created would become one of the most recognizable power plants in industrial history. The engineers made a decision that would define Detroit Diesel for the next 6 decades. They chose a 2-stroke cycle design at a time when virtually every other diesel manufacturer was committed to 4-stroke engines. It was bold, it was unconventional, and for a very long time, it was absolutely brilliant. The 2-stroke diesel cycle operates fundamentally differently from the 4-stroke engines most people know. In a 4-stroke engine, the piston makes 4 movements to complete one power cycle: intake, compression, power, and exhaust. Detroit's 2-stroke design accomplished the same result in just 2 piston movements. How? By using a mechanically driven supercharger, called a blower, to force fresh air into the cylinder, simultaneously pushing out exhaust gases through ports in the cylinder wall. No intake valves, no complex valve train, just elegant mechanical efficiency. The blower wasn't optional. Without it, the engine couldn't even start. No blower, no combustion. This design brought several revolutionary advantages. First, every revolution of the crankshaft produced a power stroke versus every other revolution in a 4-stroke engine. This meant more power from a smaller, lighter package. Second, the constant airflow kept the engine cooler and cleaner. Third, the lack of intake valves meant fewer parts to break and simpler maintenance. The Series 71 family, introduced in 1938, exemplified this philosophy perfectly. Each cylinder displaced exactly 71 cubic inches, with a 4.25-inch bore and 5-inch stroke. You could have it as an inline 6, the 671, of a V6, a V8, a V12, or even a V16 for marine applications. The modular design meant parts commonality across the entire range, but the real genius was in the unit injector fuel system. Each cylinder had its own dedicated injector, mechanically actuated by the camshaft, delivering fuel at pressures up to 20,000 pounds per square inch. This was decades before electronic fuel injection became standard. The precision of this system gave Detroit Diesels their characteristic sharp bark at idle and made them surprisingly fuel-efficient for their era. Fleet operators loved the simplicity. If one injector failed, you replace that one injector. No common rail to contaminate, no electronic wizardry to diagnose, just mechanical precision that any competent mechanic could understand. By the late 1940s and through the 1950s, Detroit diesel engines were everywhere. They powered the Greyhound buses that connected American cities. They drove the GMC and white trucks hauling freight across the expanding interstate highway system. They propelled tugboats in every major port. They hummed in the basements of hospitals and office buildings, providing backup power. The distinctive sound became the soundtrack of American industry. That unmistakable whine of the blower, combined with the sharp exhaust note, created a symphony that truck drivers called music. Old-timers still talk about running the Screaming Jimmy, named after the GMC Jimmy trucks that often carried the 671 engine. The Vietnam War cemented Detroit Diesel's reputation for durability. The 6 V53 and 8 Vi-71 engines powered the M35 and M54 military trucks that became workhorses of the conflict. These engines ran in conditions that would destroy lesser power plants: tropical heat, monsoon flooding, choking dust, and extended periods at high load with minimal maintenance. Soldiers and contractors came home with stories of Detroit Diesels running 20 hours a day, month after month, in conditions where 4-stroke competitors simply gave up. The military experience created a generation of loyal customers who would specify Detroit Diesel for the rest of their careers. By the 1970s, Detroit Diesel held commanding market share in heavy-duty trucks, transit buses, and medium-duty applications. The Series 92, introduced in 1974 with 92 cubic inches per cylinder, brought even more power. A 12-volt 92 could produce over 500 horsepower and 1,450 pound-feet of torque. Numbers that seemed almost absurd at the time. Fleet managers knew maintenance schedules by heart. Mechanics could rebuild a 671 blindfolded. Parts were available at any truck stop. The Detroit diesel two-stroke wasn't just an engine. It was an institution. Oh, and real quick, please take a moment to hit that subscribe button. It really helps out my channel. But here's where the story takes a turn. The very design that made Detroit diesel dominant was becoming its greatest liability. By the early 1980s, the regulatory environment was changing fast. The Clean Air Act amendments were tightening emission standards with each passing year, and two-stroke diesels, for all their mechanical elegance, had an inherent problem. They burned oil by design. The scavenging process that made them work so efficiently meant that some amount of lubricating oil always entered the combustion chamber. This created blue smoke and higher particulate emissions than four-stroke competitors. Cummins, Caterpillar, and the rising European manufacturers saw the regulatory writing on the wall. They invested heavily in electronic fuel injection, turbocharging, and emissions control technology for their four-stroke engines. Detroit Diesel, bound to its two-stroke legacy and confident in its market dominance, was slower to react. The company did make improvements. They added turbochargers to the naturally aspirated blowers. They refined the unit injector timing. They improved ring designs to reduce oil consumption, but these were incremental refinements to a fundamental architecture that was approaching its limits. The first cracks appeared in the over-the-road trucking market. Owner-operators who had once sworn by their screaming Jimmies started switching to Cummins N14 and Caterpillar 3406S. The reason was simple: fuel economy. The four-stroke competition, with their electronic controls and higher compression ratios, were getting 6 to 6.5 miles per gallon, where Detroit two-strokes struggled to break 5 miles per gallon. When you're running 100,000 miles a year, that difference adds up to tens of thousands of dollars annually. The characteristic two-stroke sound, once a badge of pride, became a liability. It meant higher fuel costs and clouds of blue smoke. James Mitchell, a long-haul trucker from Tennessee who had run Detroit-powered Kenworths for 15 years, told the story of his switch to Cummins in 1986. He'd been loyal to the 8V92 because he knew it inside and out. But when he calculated his annual fuel costs versus the competition, the numbers were undeniable. His fellow drivers were spending $8,000 to $10,000 less per year on fuel with their four-stroke engines. The maintenance simplicity that once gave Detroit an edge was being overtaken by engines that simply needed less frequent service because they were more efficient to begin with. Fleet managers faced similar calculations, but with hundreds or thousands of trucks. Every tenth of a mile per gallon mattered. By the late 1980s, major trucking companies were phasing out Detroit two-strokes from their purchasing specifications. Schneider National, J.B. Hunt, and other mega fleets were standardizing on Cummins and Caterpillar power. The market share numbers told a brutal story. In 1975, Detroit diesel had nearly 40% of the heavy-duty truck market. By 1990, it had fallen below 15%. The transit bus market held longer. City bus applications, with their constant stop-and-go cycles and relatively low annual mileage, still favored the durability and maintenance simplicity of two-strokes. But even here, the emissions regulations were becoming impossible to meet. The 1991 EPA standards required particulate matter reductions that two-strokes simply couldn't achieve without adding so much emissions equipment that the cost advantage disappeared. Transit agencies, many operating under federal clean air mandates, began specifying four-stroke alternatives. Detroit Diesel's response came in 1987 with the Series 60, their first four-stroke engine. It was a clean-sheet design, inline-6 configuration, 12.7-liter displacement, electronic unit injectors, and overhead camshaft. On paper, it was competitive. In reality, it was a company learning to walk in a race where competitors had been running for decades. The early Series 60 engines suffered teething problems. Electronic control modules failed. Overhead camshafts, a design Detroit had never built before, had lubrication issues. Fuel injector harnesses cracked. The mechanics who had grown up on two-strokes found themselves troubleshooting computer codes and dealing with sensors. Gary Peterson, a fleet maintenance manager in Minnesota who oversaw 200 trucks, remembered the painful transition years between 1988 and 1992. His company had been exclusively Detroit diesel for 3 decades. When they started buying Series 60-powered trucks, the problems were constant. Engines that should have been making a 500,000-mile overhaul were coming in at 300,000 miles with bearing failures. The electronic systems were so sensitive to voltage fluctuations that simple alternator problems could shut down a truck. His mechanics, skilled craftsmen who could rebuild a 671 in their sleep, were suddenly ordering diagnostic laptops and attending training seminars. The learning curve was steep, and it cost the company hundreds of thousands in downtime. Meanwhile, the competition wasn't standing still. Cummins released the M11 and N14 with CELECT electronic injection systems that were generations ahead. Caterpillar's 3406E with PEEC controls was setting new standards for reliability. Detroit Diesel was playing catch-up in a market where brand loyalty only went so far. The reality was harsh. Customers would tolerate some problems from an engine that saved them money on fuel. They wouldn't tolerate problems from an engine that cost the same as the competition but had more issues. The corporate turmoil didn't help. In 1988, Roger Penske purchased Detroit Diesel from General Motors in a leveraged buyout, along with partners including Penske Truck Leasing. The move was supposed to free the company from GM's bureaucracy and give it the agility to compete. Initially, there were improvements. Investment in the Series 60 accelerated. A new manufacturing facility in Detroit was modernized. But the fundamental challenge remained. Detroit Diesel was trying to master four-stroke technology while simultaneously defending its shrinking two-stroke business. The 1990s brought more pain. Emission standards ratcheted tighter with each regulatory cycle. The 1994 standards, then 1998, then 2002. Each one required new technology, cooled exhaust gas recirculation, higher injection pressures, improved turbocharger matching, and eventually diesel particulate filters and selective catalytic reduction. The Series 60 gradually improved. By the late 1990s, it had become a genuinely competitive engine with loyal customers who appreciated its power and durability. But the market share lost in the 1980s never came back. Production of the two-stroke engines finally ended in 1995 for on-highway applications. The 671, 8V71, 6V92, and 8V92 that had defined American trucking for nearly 6 decades were obsolete, unable to meet even the 1994 emission standards without prohibitively expensive after-treatment. Some marine and industrial applications continued for a few more years, but the era of the Screaming Jimmy was over. Mechanics who had built careers around two-stroke Detroits found themselves retraining or retiring. Parts suppliers consolidated. A whole ecosystem built around those engines gradually faded. The final chapter came in 2006 when Daimler AG, parent company of Mercedes-Benz, completed its acquisition of Detroit Diesel. What had started as GM's diesel division became Penske's independent company was now a subsidiary of a German automotive conglomerate. The Detroit Diesel name remained, but the independence was gone. The Series 60 continued production until 2011, when it was replaced by the DD13, DD15, and DD16 engines, designs heavily based on Mercedes-Benz technology. Today, Detroit engines are competitive, efficient, and thoroughly modern. They're also, in almost every way that matters to old-timers, no longer truly Detroit. The legacy is complicated. On one hand, Detroit Diesel's two-stroke engines represented a brilliant engineering solution that dominated their era. They were simple, durable, and powerful. They trained generations of mechanics and powered the infrastructure of mid-20th century America. The sound alone is part of industrial cultural heritage. On the other hand, the company's deep commitment to that technology blinded it to the coming changes. When the market shifted, Detroit Diesel was caught flat-footed, unable to compete effectively in the new regulatory and economic environment. Today, you can still find two-stroke Detroits running. Collector truck enthusiasts lovingly restore 671-powered tractors. Marine applications, less stringent in emissions requirements, keep 12-volt 92-second batteries running in tugboats and workboats. Generator sets in remote locations, valued for their simplicity and reliability, might still have a 6-volt 53 humming away. There's an active aftermarket for parts and rebuilds, but these are remnants of a bygone era maintained by people who remember what made those engines special. The story of Detroit Diesel is ultimately about the double-edged sword of innovation. The two-stroke diesel was revolutionary precisely because it broke from convention. That unconventional approach created decades of dominance. But when the world changed, when regulations demanded different solutions, and economics rewarded different priorities, that same revolutionary design became an anchor. Detroit Diesel learned to build four-stroke engines, but by then it had lost its market position and eventually its independence. In a modern diesel market dominated by common rail injection, variable geometry turbos, and complex emission systems monitored by dozens of sensors, the elegance of a mechanically injected two-stroke seems almost quaint. But for those who remember the golden age when a screaming Jimmy could haul 80,000 pounds across the country with nothing more than a screwdriver and a timing light for maintenance, there was something pure about that simplicity, something lost in the march toward efficiency and compliance. The blower whine is gone from America's highways now, replaced by the quiet hum of modern power. Progress perhaps, but not without cost.